Today's Huddle lesson will be on transformations, both linear and quadratic. You should know from your vocabulary that quadratic has to do with x squared, whereas linear is just x. Those are both the parent functions. We'll do one example of linear, and then we'll do an example of quadratic. We'll skip number 1 because it's easier than number 2 is. We'll do number 2 as the example. Number 1 is only asking to change the slope, whereas number 2 is asking you to do some multiplication with the slope and do something to the y-intercept. Alright, number 2. The graph of the line is shown on the coordinate grid. A second line is created by multiplying the slope of the original. So we don't know what this line is. We don't have the slope-intercept form, so let's go ahead and find it because we're going to have to do some stuff to it. So the easiest part is finding the y-intercept. In this case is -4. So my line y equals mx plus b. The y-intercept is -4. And now we find the slope. Any 2 points where it crosses nicely, and it appears as if it crosses nicely at every point, and it's going down, so that means it's down 1 over 1. So our slope m is equal to -1 over 1, or just -1x. So we found what our slope was, we put it in, we found what our y-intercept was, we put it in, we have our equation. Now we can do what it's asking us to do. A second line is created by multiplying the slope, which our slope is -1, by multiplying that slope of the original line by -2. So what's -1 times -2? Negative times negative is a positive, so it's 2. So our new line is 2x, and then what are we supposed to do with the y-intercept? Add 6 to the y-intercept. Well, if the y-intercept was -4 and I add 6 plus 6, what's -4 plus 6? That would be plus 2. So our new line would have a y-intercept of 2 and a slope up 2 over 1, up 2 over 1. That would be our new line. We don't have to have it graphed though. We just pick which answer choice has that, which is clearly H. So that's an example of transformation with linear functions. Just as a reminder, the slope changes how steep a line is, and the y-intercept changes whether it goes up or down. So just an example here, if it was y equals 1/2 x minus 2, that would make the y-intercept go down to 2 because that's the y-intercept, and the slope, the smaller it is, the flatter the line. So a slope of a fraction would be a real flat line, but if I made that slope something like 8, it would be a real steep line, and obviously if it was -8, it would be going down. So that's what the transformations of linear is talking about. Let's move to a quadratic. We see the parent function they included here. On some problems they don't include the parent function, such as example 4. Let's come down to example 4, or problem 4. You'll need to go back and do number 1 and number 3, the ones I'm not doing. So on example 4 it says the graph of f of x equals x squared, which you should know as the parent function, is transformed to create this. Which of the following best represents? The quadratic transformations, the vertex form of a quadratic line is y equals a x minus h squared plus k. Let's review real quick. What do each of these things do? The a in front, anything in front of the x, makes it change how steep it is. The steeper it is, the bigger the number, and the smaller it is, the flatter the number. It would make it real wide. So this might be an example of 1/2, and this might be an example of 5, making it real steep, whereas the original would be something in the middle. And remember, if the a is negative, it makes it point or open downward. So that's what the a does, changes how steep, narrow, wide it is. This middle term inside of the parentheses, that makes it go left and right. When would it go right? Normally we think of moving right on a graph if we're moving in the positive direction, but you have to remember if it's in the parentheses because of the equation formula, if it's negative, in the parentheses, that's making it move to the right. If it's positive in the parentheses, that's making it move to the left. So whatever's in the parentheses makes it move left or right. And then what does this number at the end do? The K, that's what shifts it up or down, and that's logical, like what we think of. Up is positive and down is negative. All right, knowing that, let's take a look at their example. The STAR test is tricky, where they have written it in a form that you can't just type in your calculator. If you type this in, it won't accept it because you've got multiple variables and they have it in function form. Nonetheless, what did we just say? If it's in parentheses, like this is, it makes it go left and right. So we can automatically eliminate any of them that are shifted up, like this one is. So F is out. Or that are made narrower or wider, such as J and G. Those are both out because they're making it wide or narrow. So by process of elimination, we don't even have to know which one's sending it left or right. We know it's got to be H. But just like we said before, if it's negative, we're moving to the right. So it's shifted right too. All right, that is an example of quadratic transformations. On all of these problems, you're going to be doing something along those lines. If you have a question, please raise your hand.